Hi, we are now starting Unit 2C, Linear Systems. On the Learning Portal, you'll see how to solve a system of graphing. You will see all the different I can statements, things that you should be able to do. I can define a system, determine approximate solutions, explain why there is no solution, and identify linear systems that have no solution. I'll also be able to explain why some linear systems have infinitely many solutions. As we are looking, you're going to be filling in your notes on the first page of our chapter 6, those red notes. It says, first off, vocabulary. What is a linear system? Two or more linear equations. That is what you should put in on that first box on the first page. The other thing is any ordered pair makes all the equations in a system true if it is going to be a linear system. So you should now have these two fill in. If you need to pause the video and go back to that last page, keeping in mind that that system, when we're looking at our solution, that XY point has to make all equations true. So when you plug in whatever your X and Y are, it must make both or all of the equations true. We will be filling in, you'll come a little later in your notes to see what a consistent independent system is, consistent dependent, an inconsistent system, and then you will also see that we are in this section going to be solving by graphing. And what it really means to solve by graphing, if we are looking at that, is just that we are going to always graph the two equations. So graph the two equations. Usually this is where we're going to use slope-intercept form. You might use point slope, but usually this is in your y equals mx plus b. And then you are looking for the point of intersection. And what you're trying to always find is that point of intersection. So as you are looking at yours, you're looking for the point of intersection. That's going to be our xy. We will see that there's going to be infinitely many solutions and no solutions sometimes also. Well, how do we start graphing? Here's what the problem's going to be that you're going to be taking a look at. You're going to be asked to graph y equals x plus 2 and y equals 3x minus 2. Remembering from last chapter that our start point in the first one is 0, 2, and our slope is equal to 1 over 1. That is how we started at 0, 2, up 1 and over 1 and got the red line. The second equation, the starting point is our y-intercept of 0, negative 2. And in here, our slope is 3 over 1. So down at negative 2, we have a rise of 3 and over 1. Now, usually what you want to do is you want to get a few points until you see this point of intersection. Make sure you're using and not putting extra lines in on your graph so that you can actually see that our solution in this case is 2, 4. It says, find that point of intersection. The lines appear to intersect at 2, 4. Now you need to check it. This is very important to see if it is a solution. So you plug in place of y, 4, and in place of x, 2. You need to do it in both equations. And in this case, it works in both of them, so we say it is a solution. As you take a look at that next page, what I'm going to be asking you to do is to actually graph this. We will check it in class. What you want to do is look for your slope and your y-intercept, plot the points. When you find your answer, remember, our solution is going to be an ordered pair. So we're looking for the x comma y. We're looking for that point of intersection. And you will have a point of intersection with these. And then you want to show me your check. So what I should see on your paper when you come into class tomorrow in this area is how did you check your solution. Here's a story problem. Sometimes some of you struggle a little more with the story problems as you're writing those. It says, in biology, scientists are studying the weights of 2 alligators over a period of 12 months. The initial weight and growth of each rate of the alligator are shown below. It says, how many months did the alligators, after how many months did the alligators weigh the same? Well, here's alligator 1. His initial weight was 4 pounds, but he's growing at 1.5 pounds per month. Whereas alligator 2, if we look at, started at 6 points, but is only growing at 1 pound per month. So what does this look like? We want to look at our equations. We want to relate the alligator weight to the initial weight plus the growth times time. We don't know how much time. That's what we're trying to figure out. W is the weight of our alligator. T is the time in months. So in our first case, we are starting with 4 pounds plus 1.5 pounds times t. The second alligator started at 6 plus 1t. So as we are looking at our equation, we want to think of them in slope-intercept form. So W equals 1.5t plus 4. Our y-intercept is 4. Our slope is 1.5. And our second one is we are starting at 1t plus 6, where our slope is 1 and our y-intercept is 6. Now, in this situation, in the next couple of days, we're going to see many different ways of solving systems. This first way is graphing. Now, in this case, it's a little tough to go up from our 4 up 1.5. So after time of 1 month, we should be up to 1.5. So they went from 4 to 5.5. And then we keep going up. Now, this is probably not the best way to solve this problem, but it's one way of solving it that we will know at this point. Here's another one. In the got it part, what I want you to show me is what would be your two equations. So one satellite radio station charges $10 a month plus the activation fee of $20. The second one charges $11 a month for an activation fee with an activation fee of $15. And the question is, in how many months will the cost of the service be the same? So what you want to be thinking of, if we're looking at our variables, this is still, you can think of it as cost, or this is your y-axis. This is the number of months, n, or if it helps you to go x. So if you prefer to write it in slope-intercept form using the y, or you could write each one, and if you want to think of it, you could have used c. So c is equal to what's happening. You should have something with your x, or the, in this case, n, depending on how you're doing it, and then plus your y-intercept. Again, if you do cost, you're going to have n, the rate of change n, plus the y-intercept. We are going to look at these tomorrow in class. Some of you are going to have some questions on these. You can also look in your book if you need to. I'm going to show you a couple other videos on graphing that I'll also have attached to the learning portal. Now, here's where you're going to see those other vocabulary to fill in. A system has at least one solution. It is consistent. Now, with consistent systems, it'll either be independent or dependent. What does that mean? Consistent independent means there's exactly one solution. What do we mean by exactly one solution? We have one point x comma y that makes it true. If there are infinitely many solutions, that's going to mean that it is consistent and dependent. So you can see consistent here in this table, and we have this in your notes. Same line is dependent, infinitely many solutions. Independent, there's that one point of intersection, that's our x, y. And the last one is a system with no solution, and it's called an inconsistent system. And what you're going to notice there is that your two lines are parallel. Remember, if you have parallel lines, what's going to happen is that in this case, they will have the same slope, but what actually happens is you'll notice that they have different y-intercepts. This one has 2, this one has -2. So same slope and different y-intercepts. Now, what we are going to do is we want to take a look at what does that mean. So if you would be graphing this first example, 2y minus x equals 2, and y equals 1/2 x plus 1. Now, if I'm looking at this first equation, I might want to rewrite it in slope-intercept form. And when you do that, that means you're going to add x to both sides. You would now have 2y equals 1x plus 2. Once you have that, we want to divide every term by 2, and our new equation would be y equals 1/2 x plus 1. And what you notice is that it's exactly the same as the second equation. So when we go to graph that, we start at +1, we have our up 1 and over 2, and we draw a line, and the second one is right on top of it. It says the two equations represent the same line. So any point on the line is a solution to the system. So there are infinitely many solutions. So not just these points that we see, but every little point along this line are going to be solution. In the second case, example B, you will notice that these two have the same slope, but they have different y-intercepts. so that when we go to graph those, the first equation starts at positive 2. We're going up 2 and over 1. The second equation starts down at negative 1, up 2 and over 1. These will never intersect. They are exactly parallel. So we say that our system is inconsistent. There is no solution to this problem. So the first one had infinitely many solutions. The second one had no solution. You are now going to graph this equation. My hint would be I would rewrite this equation in slope-intercept form. You are asked to graph it and tell me what your solution is. And then when you're checking your answer, when you check your answer with the infinitely many, remember whatever you pick, there's going to work in both cases. And in no solution, whatever you pick will not work.